welcome back to Atman Unlimited. We're almost there to wrapping up our machine alignment series. We did all of our table and XY alignments, and we also did our Z alignments. Now we're on to our spindle. More specifically, Spindle Tram. Spindle Tram is how perpendicular the axis of the center line of the spindle is to our XY plane. So if our spindle isn't perpendicular perfectly, our cutters are not going to cut our material on a nice level plane, and that can lead to bad cuts, inaccuracies or tapered walls, bad surface finishes, all kinds of stuff. So we want to tram our spindle. It's really easy to tram a spindle. It's not difficult to do. Some people prefer to buy specialty tooling that have a bunch of dial indicators to tram a spindle. I prefer the simple tried true method of a simple test indicator in a chuck and just sweep the arm, and we can easily tram our spindle. The other way that you can tell spindle tram is by doing a test cut. So if you use a large face mill or fly cutter, and you do a test cut at a low rate and a low depth of cut so you get a really nice surface finish. If you inspect that surface finish closely, if you see all of the tool marks and striations going in one direction, that is indicative of a spindle not being in tram. If you see striations going in one direction and then you see the other rotation as well, that is indicative of a spindle that is perfectly in tram, because the tool is cutting the part and then rubbing against it a little bit on the next time around. So that is a very well trammed spindle. So let's go over to the machine and then go through spindle tramming on our Fidel. We're at our machine again. We've got our spindle tram set up. Now when you're setting this up, what you want to do is you want to get your test indicator as far away from the axis of rotation as you can. So we're trying to measure an angular displacement in the spindle. So the farther our indicator is from the axis of rotation, the more sensitive our measurement's going to be. So once we have this set up, now we're just going to rotate the spindle one full turn, and we're going to try to find the high spot and the low spot so that we know which way the spindle is angled, if there is an angle in it. Then if your spindle is out of tram, once you know where the high side is, we can loosen the spindle from the Z column and then add some shims to then lower the high spot down a little bit so we can get our spindle trammed and in plane with the table. So let's do a rotation and then see where our measurements are and see how our spindle looks on this machine. So we're about 5/10 low there, give or take. We bump up right away by about 5/10. I know there's a high spot in the table right there. And then we're dropping back down again. So we have about a thou and a half roughly of movement in our spindle, and it looks like this side would be the low side and then the back side of the spindle would be our highest measurement. So if we were to try to shim this, we'd loosen the spindle up and put a shim on the back side to try to cant it a little bit this way. Now keep in mind we're measuring about a thou and a half across almost a 16-inch diameter circle. So if you calculate the math on that, the angular displacement of our spindle is only about 20 arc seconds, 15 to 20 arc seconds. Those are pretty small numbers, and figuring your spindle is about 4 to 6 inches in diameter, about 4, you would only want to put in a couple of 10,000ths of an inch thickness shim. So it's really not worth trying to shim out that little tiny bit of error. You really won't see it. I don't see it in any of my cuts. Most of my cuts look really good. I get striations going in both circular directions on a face mill, so the face mills are cutting really true. And again, this is across 8 inches. The biggest cutter I use is a 3-inch cutter. So across that 3-inch cutter, which is less than half, I'm going to see, you know, a couple of 10,000ths of an inch across the whole face of the cutter. So the spindle's pretty good. It's within its allowable limits. One of the other things to consider is that you're gauging this measurement off of the table. Now, way back in the first video or second video we did when we checked the plane of the table, there are some high spots and low spots in our table. So those could also be affecting this spindle tram measurement. I know on the back side of the table it's a little bit high when you get close to the edge, and I know there's some low spots around here on the X, so that could also throw your measurement off. These are all the things you have to keep in mind when you do spindle tram, and this is why you do spindle tram last. So there's spindle tram. I just covered it real quick. There's a lot of other videos out there on spindle tram. The one thing to keep in mind though is you don't want to do spindle tram first. You want to do spindle tram last after you've already trued your Z-axis head, your table, and everything is all in alignment, and just so. If you do your spindle tram first, it's pointless because you don't have a good reference on your table. So if your table's crooked and you do spindle tram and you adjust that spindle perfect, you adjusted it crooked because your reference was crooked. So that's why we do spindle tram absolute last. Okay? So I'm going to have 2 more videos on machine alignment, setup, and calibration, and they're both going to deal with ball screws. So we're going to do one video on ball screw backlash and alignment, and then another video on ball screw linear calibration. So that one's going to be pretty fun. So thanks for watching, thanks for sticking around, and we'll see you in the next episode.